We will expand some Taylor series in the following video. We will start with the easiest one. F of x is 1 over x centered at x is equal to 3. Now everybody knows the definition of the Taylor series, right? So f of x is equal to the nth derivative of f evaluated at the center, let's call it a, divided by n factorial times x minus a to the power of n. Okay, but we said that we left this at Cal 2, and here in Cal 3 we're going to expand this Taylor series with the help of the known Maclaurin series, right? So we know the geometric series, the series for sine and cosine, ln of 1 plus x e to the power of x and the binomial. Okay, so let's see which one are we going to use in order to answer our question. First of all, let's center this function at 3, which means what? I need an expression of x minus 3. So 1 over x is equal to 1 over x minus 3. Okay, artificially I'm getting this expression x minus 3 here, but in order this equal sign to be justified, I need to add the 3. Okay, so in mind, what do I have? I have the series for 1 over 1 minus x, which is the sum of x to the power of n over x to the power of n, my bad, sorry. Okay, so now I need to obtain 1 minus, and in order to make this not to confuse this x with this x, let's say 1 over 1 minus u is equal to the sum of u to the power of n. Okay, and my u in this case is going to be some expression in terms of x. Okay, so now I need to get this 1 minus whatever u is going to be in our case, so that's 3. I keep this together from now on. Okay, in order to get that 1, I'm gonna factor 3 and I get 1 plus x minus 3 over 3. Okay, and now I need one more step. Finally I have this 1 over 1, but it's plus not minus, so I'll write it as 1 over 3 times 1 minus negative x minus 3 over 3. And this is my u right here. So that's 1/3 times the sum of u to the power of n. My u is negative x to minus 3 over 3, the whole thing to the power of n, as n goes from 0 to infinity. Now, of course, we're going to make this slightly nicer. So this is 1/3. This is negative 1 to the power of n. I always want to separate that term. X minus 3 to the power of n over 3 to the power of n. And because this is a constant, doesn't depend on n, we can fit it inside the sum. And we're gonna get negative 1 to the power of n times 1/3 times x minus 3 to the power of n over 3 to the power of n, and the final answer is negative 1 to the power of n times x minus 3 to the power of n over 3 to the power of n plus 1. Our next problem asks us to find the Taylor series of cosine of x centered at x is equal to pi over 2. Okay, so as in the previous example, we start with cosine of x and we will rewrite it as, so because we want the center to be at pi over 2, we're going to write this as cosine of x minus pi over 2. I want this factor together, okay? But in order this equal sign to be justified, if I have subtracted pi over 2, I need to add pi over 2. Okay? Now, what do we know? We know what is the cosine of u. That would be the sum as n goes from 0 to infinity, negative 1 to the power of n, u to the power of 2n over 2n factorial, right? So I have to deal with this sum somehow, okay? Well, here we're going to use the trigonometric identity that cosine of a plus b is equal to cosine of a cosine of b minus sine of a sine of b. Similarly, if we find the Taylor series of sine of x, we will use the trigonometric identity sine of a plus b is equal to sine of a cosine of b plus cosine of a sine of b. Okay, but now we will use this one for our particular problem. Okay, so this is my a and this is my b. So this is cosine of pi over 2 times cosine of x minus pi over 2 minus sine of pi over 2 times sine of x minus pi over 2. Now cosine of pi over 2 is 0 and sine of pi over 2 is 1. 0 times cosine of x minus pi over 2 makes this whole term become 0. And we obtain only negative sine, negative times 1, negative 1 times sine of x minus pi over 2. Or in other words, cosine of x is simply negative sine of x minus pi over 2. And now I'm going to find the Maclaurin series of this expression. Well, what is the Maclaurin series of sine of u? Negative 1 to the power of n, and starts with 0, u to the power of 2n plus 1 divided by 2n plus 1 factorial. So this is our u, and this is equal to negative times the sum of negative 1 to the power of n x minus pi over 2 to the power of 2n plus 1 over 2n plus 1 factorial. Finally, don't forget that this negative 1 can be included within the sum. So that's negative 1 times negative 1 to power n. That's negative 1 to power n plus 1. Times x minus pi over 2 to power 2n plus 1 over 2n plus 1 factorial. And the last example that we will do in expanding this Taylor series is find the Taylor series of f of x is equal to square root of x centered at 49. So similarly like in the previous two examples, or for similarly like you're gonna solve any problem of this type, the first thing that you want to do is obtain that x minus 49, x minus a, right? You want to center it at 49. So that's the square root of x minus 49. And if we have subtract 49, then we have to add 49 here. And this is equal to 49 plus x minus 49 to the power of 1/2. Now obviously the exponent here gives it out. We're talking about the binomial series, and the binomial series says that 1 plus x to the power of k is equal to 1 plus kx plus k times k minus 1 over 2 factorial x squared plus k minus 1, k minus 2, and this factor here is k minus m plus 1 over n factorial, and this is the constant times x to the power of n plus, and so on and so on. Okay, so I should have used here u as in the previous examples, but now it's too late. So I want 1 plus this expression in terms of u. In order to obtain that one, I need to factor 49 here, so that's 49 times 1 plus x minus 49 over 49. Okay, so I have factored 49 from this expression. Don't forget that the whole thing is raised to power 1/2. Okay, so this ends up being 49 to power 1/2, or that's just square root of 49, times 1 plus x minus 49 over 49 to power 1/2. Now, 49 to power 1/2 is just 7, right? The square root of 49 is just 7. And now we have just to apply the binomial expansion right here for this term. So this is going to be equal to 7 times the first term in the binomial is 1 plus this is my k, 1/2, and this is my x here, or what we called in the previous case is u, so that's x minus 49 over 49 plus 1/2 times 1/2 minus 1 is negative 1/2 over 2 factorial x minus 49 over 49 squared, let's put these square brackets, plus 1/2 times negative 1/2 times 1 less is negative 3 over 2 over 3 factorial x minus 49 over 49 cubed plus, and now we can go to the nth term. That's 1/2 times negative 1/2 times negative 3 over 2 times 1/2 minus n plus 1, right? The nth term right here, k minus n plus 1 over n factorial times x minus 49 over 49 to the power of n, and of course this continues. Okay, now you want to figure out what this is equal to, right? Which is very simple. 1/2 minus n plus 1 is equal to 1 minus 2n plus 2, or simply 3 minus 2n over 2. Okay, so this can be written as 7 times 1 plus 1/2 x minus 49 over 49. And here I have 1 times 1, and I'm going to write that down. So minus 1 times 1 over 2 times 2, that's 2 squared, times 2 factorial, x minus 49 over 49. Here I have negative times negative is positive. Okay, 1 times 1 times 3 over 2 times 2 times 2 is 2 cubed times 3 factorial. Try to figure out the pattern as early as possible, and as you can see, the exponent of this 2 coincides with the factorial in the denominator, and of course to the exponent of this term here, so x minus 49 over 49 cubed. And in a way, what are we doing? In a way, we're factoring all the negatives from these terms, right? So plus, and here I have 1 times 3 from this term. If I factor the negative 1 from this guy, I'm going to have 2n minus 3 over 2 to the power of n, because I'll have n of these, right? And times n factorial, and here I have x minus 49 over 49 to the power of n plus, and so on and so on. Okay, so this now is equal to 7 times. Now, as we can see, I want this this one at the beginning here, in a way it can be forgotten. Why? Because it's just 1 times something. So where does the pattern start, right? For what n? So I have 1 times 3 times 5 and so on, and times 7 and so on and so on. But when will it start becoming positive? When n is equal to 2, right? When n is 1, I'll have negative. When n is 0, I'll have negative 3, right? So my sum is going to start here when n is equal to 2. N is equal to 2, here n is equal to 1, and this guy is when n is equal to 0. So in order this term to be positive, I will start at 2, so that means that I'm going to keep these two terms outside of the sum. 1 plus 1 half x minus 49 over 49 plus the sum as n starts from 2. And now basically this term tells me what is going to be my expression right here. So that's 1 times 3 times 5 times 2n minus 3 over 2 to the power of n times n factorial x minus 49 to the power of n over 49 to the power of n. Of course, you can check that. When n is 2, 2 times 2 is 4, minus 3 is 1. So I just get 1 in the numerator. 2 to the power of 2, here, 2 factorial, right here, and then x minus 49 over 49 squared. When n is equal to 3, I have 2 times 3 is 6, minus 3 is 3, so indeed I have 1 times 3, right? Over 2 to the power of 3 times 3 factorial, I obtain this term, and so on and so on. The only thing that we have to do, we have to adjust what? We have to adjust the alternating series. As we can see, the first term where the series starts is negative, so that's negative 1 to the power of n minus 1, because n is 2, right? And now what do we have to do? We just have to make this series slightly better looking. Okay, so this is going to be equal to, now let's drop the parentheses, sorry, these square brackets. So I have 7 plus 1 half times x minus 49 over 7, because this 7 and this 7 will cancel, plus the sum, n starts with 2, negative 1 to the power of n minus 1. If somebody feels confident, 1 times 3 times 5 times so on and so on and so on, times 2n minus 3 can be written as 2n minus 3 double factorial. Okay, 2 to the power of n times n factorial times, in the denominator, I have, so times 7, right, this 7 from here, and 49 to the power of n is 7 squared to the power of n, which is 7 to the power of 2n, 7 to the power of 2n, times x minus 49 to the power of n. Now, of course, this 7 will cancel out with this guy, or it simply will come on the bottom. So it's going to be 7 to the power of 2n minus 1 times n factorial times 2 to the power of n, 1 times 3 times 5, all the way to 2n minus 3, negative 1 to power n minus 1, and then you can multiply just this. So this is the Taylor series of square root of x centered at